Okay, so the last thing we're going to introduce with respect to sets is the concept of a frozen set. Now, a frozen set has the same characteristics as a set, so for example, they will only include unique values and the duplicates will be removed, but a frozen set's elements cannot be changed once assigned. So while tuples can be thought of as immutable lists, because you can't change a tuple's elements once they've been assigned, frozen sets are essentially immutable sets. In other words, you can't change an element of a frozen set. Now, frozen sets can be created using the frozen set function. So let's start by creating a normal set and we'll call the variable a. And we'll set this equal to a call on the built-in set function, and inside parentheses, we'll pass a list of integers from 1 to 5. We'll then create a second set labelled b, and we'll have the integers run from 4 to 8. Now I'll copy the exact same code for variables a and b, but this time I'll relabel them to be c and d, and I'll change the built-in function from set to be frozen set. Now, if we take a look at the type of variable a, you can see we obtain the type set. And if I take a look at the type of variable c, we get back a type of frozen set. So it's its own class, it's its own object, and therefore they're treated differently. Now, with sets being mutable, it means we can't use them as dictionary keys. So for example, if I create a dictionary called my_dict, and I then set this to a set of curly braces, and we have the first key to be the variable a, and we set the value to be a string stating 1 to 5. I can then have a second item with the key b, which refers to our variable called b, and I can then provide this a value with the string 4 to 8. Now, when we try to run this, because we're using sets here as keys, and we know sets are mutable, we get back a type error, telling us that we have an unhashable type. However, with frozen sets, because they are immutable, they are therefore hashable and can be used as keys to a dictionary. So if I change the keys in this dictionary which gave us an error to be c and d respectively, when we run this, we no longer get back an error. And I can now utilize the frozen set as a key. So if I was to now run my_dict and place square brackets afterwards, and we try to access the value associated with the key c, which we know is a frozen set, we get back the value 1 to 5. So just by utilizing a frozen set means we get some flexibility on the dictionary key labeling. However, we do not get flexibility in changing elements of a frozen set. So if we take a look at the options available to us with respect to methods by accessing the methods on variable a, we can see we have many options, including the one at the top stating add. Now, if I take a look at the options available to us on variable c, i.e. the frozen set object, you can see we have far fewer options, and add at the top is not a method we can call because we are unable to add or remove elements from a frozen set. However, we can use frozen sets in the set operations that we've just discussed. So for example, union, intersection, difference, and symmetric difference. Now, one thing I want to point out here is that if you are using frozen sets in your operations, so for example, if we were to do c pipe d, because both variable c and d are frozen sets, we will end up returning a frozen set object. Now, interestingly, if I start with the variable c and then union variable b, which is the set equivalent of the frozen set, we also return a frozen set object. Now, this is because we've stipulated the frozen set first. So even though we're performing a union between a frozen set and a normal set, we bring back a frozen set. Now, if I switch this around and we try to union variable a, which is the numbers 1 to 5 of a normal set, and we union this with variable d, which is the frozen set with integers 4 to 8, you can see that we bring back a normal set. So we could assign this to a new variable and then utilize the functionality of a mutable object. So depending on whether you include a set as the first item in the set operation, you will obtain the same object type. So make sure you're returning the type that you're expecting to return. So just to summarize, a frozen set is very similar to a normal set, with the difference being they are immutable objects. So you can't add or remove elements to a frozen set. You can use frozen sets as keys in dictionaries because as they are immutable, they are therefore hashable, and you will not run into the type error as you do when you use sets as keys. And finally, frozen sets can be used in the set operations such as union, intersection, difference, and symmetric difference. And if you're using two frozen sets in the operation, you will return a frozen set object. If you use a combination of a set and a frozen set in the set operation, you will obtain an object which is identical to the type of object you place first in the set operation.